everyone, myself Neha Shah from the Institute of Engineering and Technology from the Department of Electronics and Communication. Today I am going to explain you some examples based on that transform from the fourth unit, which is that transform from the subject of signals and systems. In the last session, I will explain you the basic concept of that transform, types of that transform, then I will explain you the convergence of that transform means you will find in the ROC of it. Then I have also covered the properties of ROC. Right. Now, from the properties of ROC, the fifth property is for the finite duration sequence. So we will be covering the examples of that transform in this session based on the finite duration sequence. So for this, first of all, if we starting with the first example, find the Z transform of x of n equals to 1, 2, minus 3, 0, 5 and 7. Now we can see that the number of terms are finite. It means this sequence will consider as finite duration sequence. In this, suppose arrow is given to you below the 1. So what this arrow indicating? It indicates that the position of n equals to 0. So n equals to 0 will be over here. So if you want to solve this example, first of all I am drawing the graph of this sequence. So you can see that if I am drawing the graph of x of n, it will look like this. X of n is the function of n. So on the x-axis we will draw the n, and on the y-axis we will draw the x of n. Right. Now here you can see that on n equals to 0, its value will be 1. So on n equals to 0, I have drawn 1. N equals to 1. After n equals to 0, the next term will be n equals to 1. Right. So on n equals to 1, the value of x will be 2. So on n equals to 1, I have drawn 2. The next term is minus 3. So on n equals to 2, its value will be minus 3. Likewise, all the other terms I have drawn. So this is the final graph of this x of n. Now, if you want to solve this example to find out the Z transform, so as I told you in the last session that to solve any example of Z transform, we are starting with the bilateral Z transform equation. Right. So, starting with this, we are writing the equation of Z transform as Z transform of x of n equals to x of z, and its value equals to summation n equals to minus infinite to infinite x of n is to minus n. So this one is the equation of bilateral Z transform, right? Because we have covered the whole range, entire region minus infinite to infinite. Now in this, what is the range of this x of n? You can see from this graph that from n equals to 0 to 5, this graph of the input sequence will be there, and after and before that its value will be 0. So this range will convert from n equals to 0 to 5. So x of z equals to summation n equals to 0 to pi x of n into z raised to minus n. Now we will put in the values of n in this equation. So the term will be x of 0 z raised to 0 plus x of 1 z raised to minus 1 plus x of 2 z raised to minus 2 plus x of 3 z raised to minus 3 plus x of 4 z raised to minus 4 plus x of 5 z raised to minus 5. In this equation, if I am putting the value of n, then it will give you this one, right? Now, what is the value of x of 0? X of 0 means on n equals to 0, what is the value of x? Its value will be 1. So over here in the first term I will put 1. Now the next term is z raised to 0. What is the meaning of z raised to 0? Z raised to 0 means 1. So the next term will consider as 1 into 1. Right? Plus, now the next term is x of 1. What is x of 1? X of 1 means on n equals to 1, what will be the value? Its value will be 2. So I am putting over here as 2 into z raised to minus 1. Similarly, I will put all the other terms like minus 3, 0, 5 and 7. So minus 3, 0, 5 and 7. So the term will be minus 3 into z raised to minus 2 plus 0 into z raised to minus 3 plus 5 into z raised to minus 4 plus 7 into z raised to minus 5. Now, if we simplify this equation, so it will give you the term as 1 into 1 means 1, 2 into z raised to minus 1 means 1 by z, 2 into 1 by z means 2 by z, right? So if I am simplifying this term, it will give you the term as x of z equals to 1 plus 2 by z minus 3 upon z square plus 5 upon z raised to 4 plus 7 upon z raised to 5. So this is the final answer of the z transform. as I told you in the last session that it will finding the Z transform, along with that will also finding the value of ROC. So if you want to find out ROC for this, what will be the ROC for this? Recalling the definition of ROC, what is ROC? Will finding the set of Z for which X of Z should converge. It means will finding the set of Z for which the value of X of Z will become finite number only. It should not have the infinite term. Okay. So in this equation, if I am putting Z equals to 0, then it will give you the infinite answer. Right? Except is Z equals to 0, all the other terms can give you some finite number. So when I am putting Z equals to 0, that is time only it will give you the X of Z equals to infinite. So what will be the ROC? ROC is entire Z plane except Z equals to 0. We will not including Z equals to 0 in this portion. So if I am drawing the ROC for this, then the ROC will be drawn on the Z plane. This one is Z plane. Z plane will be drawn on the x-axis. We will draw the real part of that. On y-axis, it will use the imaginary part of that. Now this will show in the entire region of the Z plane. But in this, we will not include Z equals to 0. So this Z dot will not include in the ROC of the example. So this way we can calculate any example based on this. Now the next example is find the Z transform of X of n equals to this. I have taken the same example, but in this we have taken the arrow on the last point. So as you can see that this one is the finite rotation sequence. So similarly, we are finding the Z transform of this one. So if you want to find out Z transform, first of all, I am starting with the signal. Input sequence will be drawn like this, X of n. This arrow is showing the n equals to 0. So before n equals to 0, what will be the number? N equals to minus 1, right? So on the n equals to 0, the value will be 7. On n equals to minus 1, its value will be 5. Likewise, we have drawn all the other terms. So this one is the final answer of X of n. Now from this graph, you can see that the range of n will be minus 5 to 0. So starting with the equation of bilateral Z transform, which is Z transform of X of n equals to X of z, and its value will be summation n equals to minus infinite to infinite X of n into z raised to minus n. In this equation, we are changing the range of n. The range of n will change according to this graph. Then what will be the range of n? N's range will be minus 5 to 0. So this will be converted in this form X of z equals to summation n equals to minus 5 to 0 X of n into z raised to minus n. Now in this we will put in all the values of z in this range, right? So what will be the equation? X of minus 5 z raised to minus 5 plus X of minus 4 z raised to minus 4. Likewise, X of minus 3 z raised to minus 3 plus X of minus 2 z raised to minus of minus 2. Because instead of 10 we have taken this minus term, right? So overall it will convert in the form of minus plus term. So if we will simplify this term, after putting the values of this, it will give you the next term as X of minus 5 means on n equals to minus 5, what will be the value of X? Its value will be 1, right? So instead of X of minus 5, I have taken 1. Z raised to minus 5 means Z raised to 5 plus X of minus 4. On the minus 4, its value will be 2. So the next term will be 2 into Z raised to minus 4 means Z raised to 4 minus the next term is minus 3. So minus 3 into Z raised to minus 3 means Z raised to 3 plus next term is 0. So 0 into Z raised to minus 2 means Z raised to 2 plus the next term is 5. So the 5 into Z raised to minus plus 1 plus 7, last term is 7 into Z raised to 0. Now what is the value of Z raised to 0? Z raised to 0 equals to 1. Now we will simplify this term. So what will be the next step? It will give you the term as X of z equals to 1 into z raised to 5 plus 2 z raised to 4 minus 3 z raised to 3 plus 0 into z raised to 2 plus 5 z raised to 1 plus 7 into 1, right? Up to this we have already solved in the last step. Now if I am simplifying this term, it will give you the term as 1 into z raised to 5, z raised to 5 plus 2 z raised to 4 minus 3 z raised to 3 plus 5 z plus 10 into 1 is 7. So this is your final answer of x of z. Now we have to find out ROC of this. So what will be the ROC for this? In this equation, if I am putting z equals to infinite, then it will give you the answer as x of z equals to infinite. For any other value of z, it will give you the finite number of x of z, right? So it will give you the finite output. So we will not include only the term z equals to infinite from this. So for z equals to infinite, this value becomes x of z equals to infinite. So we will not include z equals to infinite in this transformation. So ROC we consider an entire z plane x and z equals to infinite. We will not include z equals to infinite, right? So what will be the ROC? ROC will be entire z plane x and z equals to infinite. And we can't show z equals to infinite term. So we are considering that we will taking all the finite terms and at z equals to infinite we will not including that part in this ROC. Now the next step is find the transform of x of n equals to this. In this also we have taken x of n being it is taken as finite duration sequence, but in this I have taken arrow below the 0. So it will be considering 0. After 0 it will be considering n equals to 1, n equals to 2. And before that the term will be n minus 1, minus 2 and minus 2. So what will be the range of it? Its range will be from minus 3 to 2. So if we are drawing the graph of this sequence, so it will look like this x of n versus n. You can see that on n equals to 0 its value will be 0, or n equals to 1 its value will be 5, on n equals to 2 its value will be 7. Before 0 its value will be minus 1, so on n equals to minus 1 its value will be minus. Likewise around whole the sequence. So this one is x of n. Starting with the equation of bilateral z transform. What is the equation of bilateral z transform? Z transform of x of n equals to x of z and its value will be summation n equals minus infinite to infinite x of n equals to minus n. Right. Now in this, according to this graph, the range will be changed. So now what will be the range? From minus 3 to 2. So x of z equals to summation n equals to minus 3 to 2, x of n equals to minus n. Now in this equation, we are putting the values of n equals to from minus 3 to 2. So what will be the term? X of minus 3 z raised to minus plus 3, x of minus 2 z raised to 2 plus x of minus 1 z raised to 1. Likewise, whole the term will be like this up to n equals to 2. Now in this, if we are taking the value of x of minus 3, on minus 3 its value will be 1. So instead of x of minus 3 we have taken 1. X of minus 2 we consider as 2, x of minus 1 we consider as minus 3. Likewise, I have taken all these values over here. So this one is the final term. Now if I am simplifying this term, then the next term will be considered as 1 into z raised to 3, z raised to 3 z square minus 3z plus 5 upon z plus 7 upon z. So this one is the final answer of that transform. Now from this, you can see that if I am putting the value of z equals to 0, then it will give you 5 upon 0, means it will give you the infinite term, right? Similarly, if I am taking z equals to infinite, so 3 into z, so 3 into infinite will give you the infinite term. Similarly, we consider in all the other terms like 2z square. So infinite square means infinite, into 2 means infinite. If we are including any one term as infinite, so overall answer will be infinite. So for z equals to 0 and z equals to infinite, it will give you the answer as x of z equals to infinite. So in the ROC, we will not including these two terms. So ROC will consider as the entire z plane x z equals to 0 and z equals to infinite. So if I am drawing the graph of this, then it will look like this. ROC is entire z plane x z equals to 0 and z equals to infinite. Now you can recall from the last session that fifth property of the ROC. What is the ROC for the finite duration sequence? it will be considered as entire Z plane except Z equals to 0 and Z equals to infinite, right? So according to the different range, it will give you the arrow in this range only. Okay. Now, suppose if I am giving similar type of example like x of n equals to 3, minus 2, 0, minus 1, 5 and 4. But in this example, if I am not giving arrow indicating the position of n equals to 0, right? So according to the position of arrow, the answers may be different. But here, I am not including the arrow in this example. So for this kind of examples, we consider that below the first term it will consider as the arrow. So this x of n I will written over here. In this you have to consider that the first term is considered as arrow. It means the position of n equals to 0. Now suppose if I am drawing the graph of this, then it will be representing like this x of n. On n equals to 0, its value will be 3. Then the next one is minus 2. On n equals to 1, its value will be minus 2. Then the next term is 0. So on n equals to 2, I am representing it as 0. Then the next term is minus 1, next one is 5, and the last one is 4. So on n equals to 5, its value will be 4. Now, if you want to find the Z transform of this sequence, so starting with the equation of bilateral Z transform. So what is the equation of it? Z transform of x of n equals to x of z equals to summation n equals to minus infinite to infinite x of n z is minus n. Right. In this, we have to convert this range according to this graph. So what will be the range? From n equals to 0 to 5. So over here I can change the range of this. So what will be the value of x of z? X of z equals to summation n equals to 0 to 5. X of n z is minus n. Now in this I will put different values of n from 0 to 5. So the values will be x of 0 z is to 0 plus x of 1 z is to minus 1, likewise up to 5 and x of 5 z is to minus 5. Right. Similarly we will finding or we will put in all the values of x of n. Like x of 0 equals to 3, x of 1 equals to minus 2, x of 2 equals to 0 in this term. So it will give you the term like this. Now if you simplify this term, then it will give you the term as 3 minus 2 by z minus 1 upon z cube plus 5 upon z raised to 4 plus 4 upon z raised to 5. So this is the final answer of x of z. Now in this example, if we will taking z equals to 0, then it will give you the infinite output. So we will not including z equals to 0 in this. So what will be the ROC? For z equals to 0, x of z equals to infinite. So we will not including z equals to 0. So except z equals to 0, the entire z plane will consider as the ROC. So when we are drawing the ROC is the entire z plane except with z equals to 0 point. So this way we can find out the transform of any finite duration sequence and ROC of it. From the next question, I will take this transform of some standard figure.